In this video, we're going to take a look at solving systems of equations in the form of word problems. There are three different kinds of word problems that we're going to explore, and these will be the three traditional word problems that you'll see on quizzes, tests, and the ACT with regards to applications of systems. If we take a look at our first example, we're told that we need to buy 8 packages of meat for a cookout, that a package of hot dogs costs $1.60, and a package of hamburgers costs $5. We need to spend a total of $23. We want to find out how many packages of each we can buy. The first thing we always need to do is to define our variables. So if I look back through this word problem, I'm trying to figure out what two different things am I talking about. Those two different items are going to define my variables. So if I take a look, I have one type of item is the hot dogs. Those cost $1.60. We'll need to know that later. The other thing that I know is that I have hamburgers, and those cost $5. So my two items, the two things that I'm purchasing, are hot dogs and hamburgers. So those are going to define my variables. So I'm going to always use values or variables that make sense. I can't use H in this case because they're both H. So I'm going to choose to use D for dogs, or the number of hot dogs. And then for burgers, I'm going to use B for burgers. So in any word problem, you're trying to figure out what are the two different items. Those become your variables. Now I want to write a system. My system is comprised of two different equations. One equation is going to represent the total amount of items. Well, I'm going to buy dogs and burgers. So I'm going to have D plus B. And they told me that my total number of items, they told me that I bought 8 packages of meat altogether. So this is going to equal a total of 8. The amount of items that I bought. Right? Then I need an equation that's going to represent my total cost of the items. Well, my total cost is $23. So this would be similar to shopping. Every hot dog is worth $1.60. So it's 1.6 times every dog plus every burger is worth $5. So 5 for every burger equals a total cost of $23. So notice all of these, $1.60, $5, and $23, they were all dollar amounts. The 8 was something totally different. Nothing in here has any dollar amounts because we're not talking about the value, we're talking about the total number. These two equations create my system. And now I can solve in any manner that I want using either substitution or elimination. I tend to use the elimination method for each of these, but you could easily use the substitution method. So go ahead and pause the video, solve, and then check your final answer against my work, including a sentence. Okay, this type of format, this format is going to always be used anytime you're talking about two different items. Okay, so every time I'm talking about two different items, you're going to define your variables, write your system using this format. The one equation to represent the total number of items, the other equation to represent the total cost, and then you'll solve. Final answer needs to be written in a sentence. Let's try a second example. Okay, this one's similar, but this time we're talking about interest rates. Okay, so this one will always be a type of problem where we're dealing with interest. Okay, for interest rates, we're given this example, and it's turning out 2 loans. So we're going to be talking about 2 different loans. in order to open her law office. The interest rate on her one loan was 12%, and the interest rate on her second loan, or the other loan, was 15%. The total amount borrowed was $25,000. Her total interest expense was $3,510. Find the amounts of each of the two loans. Okay, so I have two different loans. When I'm looking through this, my two different items are my two different loans. Okay, so I have the amount of money for my first loan and the amount of money in my second loan. Okay, I need something that I can connect those two. Okay, so I'm going to choose to use just simply X and Y, since I'm talking about both loans. You could also choose F for first and S for second. Okay, I need to write my system. I need one equation to represent the total amount invested. Right? The total amount borrowed or invested was $25,000. So for this equation, I'm going to say X plus Y, my two accounts total, gave me $25,000. Now it's important that the next equation is only talking about interest earned. So for the interest earned on my first amount, right, my interest rate on loan 1 was 12%. So I'm going to do 12% times X for my loan 1. I always represent percents as decimals, so 0.12 times X plus, okay, the interest rate on the second loan was 15%. So 0.15 times Y and equals my total amount is $3,510 that I got off of interest, total interest. Okay, so this is my system, and I'm going to solve. Since I told you could use either substitution or elimination, and while I prefer elimination, substitution can be used, I'm going to do substitution for this particular problem just to illustrate that. So go ahead and pause the video, solve, and then check your final answer against my work, including a sentence. So to answer my final question, right, find the amounts of each of the two loans. So the first loan was for $8,000. The second loan was for $17,000. Okay, if I want to check my work, right, I would plug these back in, the 8,000 in for X, the 17,000 in for Y, and check to make sure that I got $3,510. In summary, I want to define my variables still like I did in the first example. I'm writing my system again like I did, but this time one is representing the total amount invested, the other one is representing just the total amount of interest. I solve, again using any method, and then final answer in a sentence. Last example. Last example deals with money, right? And specifically, it deals with coins. Coin problems will have the least amount of information given to you, and that's because we know the value of coins. It's assumed that you know that. Okay? So a quarter I know is worth 25 cents, so they don't have to tell us that. A nickel I know is worth 5 cents, and make sure you put 0.05. Students tend to put 0.5, and that would be 50 cents. Okay, so to find my variables, well, Jerry had 11 coins in his pocket totaling $1.75. He only had quarters and nickels, and how many of each coin did he have? So I have quarters as my one variable, and nickels is my other. So my variables, I'm going to use Q for the number of quarters, okay, and then I'm going to use N for the number of nickels. Again, I want to make it as easy on myself as possible, so I'm choosing variables that will make sense to me in my final answer. Okay, write an equation. Again, my first one is to write an equation based on the total number of coins. Well, I have 11 coins, so I'm not actually doing anything with dollar signs yet. Okay, so total number of coins, Q, plus N equals 11. Okay, total value of my coins was $1.75. And that's where I'm going to use the values of my quarter and nickel. So a quarter is worth 25 cents, so 0.25 Q. A nickel is worth 5 cents, so 0.05 N. And this gives you a total of my $1.75. So this is my system. And again, to solve either method, elimination or substitution, this time I'm going to go with elimination. So negative 0.25 is what I'd need to multiply all three terms by in order to create opposite coefficients. So that gives me negative 0.25Q minus 0.25N, and this gives me negative 2.75. I'm going to rewrite the second equation, 0.25Q plus 0.05N equals 1.75. When I add these up, if I've done my job correctly, my variables should cancel. So the Q's or the quarters are gone. If I add this up, I'm left with negative 0.2N. And that equals, I'm left with negative $1. If I divide both sides by negative 0.2, N is going to equal 5. Well, if I have 5 nickels and I have 11 coins total, the number of quarters that I'm going to have is 6. Final answer, he has 5 nickels and 6 quarters. Again, in review, I have defined my variables, Q and N, for quarters and nickels. Those were the two things I was talking about. I wrote my system based on the total number of items, then the value of the coins. I solved and wrote my answer in a final sentence. So while each of these three problems are slightly different because they're talking about slightly different content, the general format is the same for all three.